Hello, robot.
Yes, I'm here.
Set to red.
Okay.
Here is my project using a speech recognition module to trigger sound files from a sound module. The project uses a Raspberry Pi Pico microcontroller and Micropython code to control two hardware modules. One hardware module is the DF Robot Offline Language Learning Voice Recognition Sensor. It can recognize spoken voice commands from its built-in microphone and then send a serial data command to the Raspberry Pi Pico. No connection to the internet is needed. The second hardware module is the DF Robot MP3 voice prompter. It will play one of many tracks of spoken words or music that are stored in its very large memory. A selected track of sound is played on its built-in speaker when it receives a specific serial data command from the voice recognition module via the Raspberry Pi Pico. Here is the player with its USB data transfer cable. The offline voice recognition sensor can recognize spoken input received from its microphone. Recognition includes 121 built-in voice commands. It can be trained to recognize 17 additional custom commands. The module will interpret each voice command and generate a command ID code, a decimal number. The command ID value is sent to the Raspberry Pi Pico via the I2C bus. The Micropython script generates a 7-byte hex code, track number and other actions that the MP3 player can recognize. The track code is sent from the microcontroller to the MP3 player via a serial communication interface, UART. The MP3 player module has two pins, RX and PX, for UART serial data input and output that enable triggering of any soundtrack stored in the player's memory. The module has USB data port pins, U+ and U-, to enable loading and arranging sound files into its memory. Here are the pinouts of the player for loading sound files via USB, U+ and U-, and for RX and PX serial data transfer. The MP3 player can store MP3 WAV and WMA sound files in its 16 megabytes memory. Each track code, 7-byte hex, that is sent to its UART port will trigger a specified soundtrack in the MP3 player. Other commands allow control of MP3 player's volume and other functions. Here is a sample of some of the command codes. It is not obvious how to send these codes in a Micropython script. The correct format for sending these instructions to the MP3 player via a UART is shown here for tracks 1, 2, and 3. I assembled the two hardware modules on a breadboard along with the Raspberry Pi Pico as shown here. Here is the project breadboard reacting to voice commands, playing an MP3 music track and lighting a specified LED.
Hello, robot.
Yes, I'm here.
Set to red.
Okay.
Set to green.
Okay.
Set to white.
Okay.
Turn off the light.
Okay.
Here is a demonstration of my Micropython code directing the voice recognition sensor to send commands to activate each of several one of MP3 music tracks as well as lighting one of 3 LEDs of different colors. A small portion of the Micropython script is shown while it is running in the Thani Python Integrated Development Environment, IDE. The lower half of the screen shows the Thani shell where it receives command IDs from the voice recognition sensor. Then Thani sends a command to the MP3 player to play a track.
Hello, robot.
How can I help?
Set to red.
Okay.
Set to green.
Okay.
Here is a warning about loading any of your audio files into the MP3 player module. When connecting the USB cable that is supplied with the module, the visible metal parts of the USB cable's connector must be facing up as shown here. I connected the cable to the U+ and U- pins with the metal area facing down. The module immediately became very hot. I contacted DF Robot personnel and got instructions on how to connect the cable. Luckily, my module was not damaged.
Turn off the light.